Number 3 says, a music dealer ran a sale of records and tapes. Records were reduced to $7 each, and tapes were $7.50 each. The music dealer sold 60 more records than tapes for a total sale of $21.60. How many records did the actual music dealer sell? All right, so the reason this could be confusing at first is if you don't write a relationship between the two different things that are being sold, you end up with two variables. So you might have ended up with like an x and a y, and then you need two equations, which you may not have solved, you may not have done it yet, but that's called a system of equations. To alleviate that problem, what we can do is we can write a relationship that exists among these two or between these two different things. So, first of all, records were $75 a piece, or no, not 75, $7 a piece. And what is the other one? Tapes. Tapes are $7.50. You can tell how old this book is, by the way, right? Anybody even know what a record? What do they mean by record? Yeah, like an original vinyl, like a 45. So records and then tapes, even tapes now, right? We don't even have tapes anymore. It was funny, the other night I was cleaning my grandma's house and I found original, like, 8-track, the original, like, cassettes, before cassettes. Do you guys ever see cassettes before or no? Even before cassettes were out, there were 8-tracks. But I don't have a player for it, so I can't even play it.
I still use it on the bars.
Do you really?
I have one, it's just to be cool, I have it.
But you have a bunch of records?
Yeah.
Nice. That's awesome. I had a friend who recently got rid of 1,000 records. He had like it was his grandfather's and father's or something, but he sold like 1,000 records to somebody for like so cheap because now nobody uses records anymore. It's a good collection to keep. You should look for some old vintage ones. And the sound comes out so much different too. And the sound quality's night and day. Anyway, so records are $7 each, tapes are $7.50 each. The record dealer or the music dealer sold 60 more records than tapes. So we know that the number of records, we can say that, let's say X equals, it was 60 more records than tapes. So let X equal the number of tapes sold. Now, right away you might want to say, let Y equal the number of records sold. But instead of putting a Y here, we can write X with something else involved in it. And the statement that's made is that the music dealer sells 60 more records than they do tapes. So how would I write that? If there's 60 more records, 60 more than what we have for this. Well, X plus 60. Okay, is the number of records sold. All right, so we have two different things then. We've got our amount of tapes sold and amount of records sold, but they're both in terms of this variable x. That allows us to solve only one equation. If we set one of these equal to y and didn't consider that, we would need two equations and two variables. We're missing one person. Who's missing? Where's Nico? He was here today. I saw him. Did you guys see him?
Yeah.
I definitely saw him in the hallway. Check in a minute. Okay, so hey, never mind. You just showed up. I was missing a student. Thank you. Are you good?
Yeah, Cote was playing Gregorian chant and he was going to get it up.
Gosh. So everybody being late? All right, so the number of tapes sold is X. The number of records sold is X plus 60. We know that records cost $7 a piece, so we could take this 7 up here and multiply it by this X plus 60. We know that tapes cost $7.50 each. Multiply that by X, and we're told that the person sells $2,160 worth of equipment, or whatever this is. So $2,160 is the sum of the amount sold. Again, records at 7 apiece, and there's X plus 60 records. And then tapes are $7.50 a piece, and there are X amount of tapes sold. Okay? And then from there, James will sell. Okay? So solve for X, shoot at 7, etc., etc. The other one was what, 13, I think somebody said? Is that right, Christian? 13? All right, number 13 says, well, first of all, it says, in problems 13 through 18, find the solution if possible. If there's not enough information to solve the problem, or if it has no solution, say so. If extra information is given, like extraneous, identify it. Okay, so the directions here are different. So let's take a look at number 13. 13 says, 2 planes leave Wichita at noon. So I'm going to start right away. Here's what I visualize. There's Wichita. I don't know which way yet. It then says, one plane flies east at 30 miles an hour faster than the other plane, which is flying west. So take a look at what I wrote right away. Going east is the one plane flying at a rate of r plus 30 miles an hour, more than r, which is the rate of the other plane, which is traveling west. Again, so the plane traveling east, it says one plane flies east 30 miles per hour faster than, so I know I have a plus 30 already for the rate, faster than the other plane, which is flying west. The question then says, at what time will they be 1,200 miles apart? Can I get a suggestion here? What do you think's going on with this problem?
Can't really tell if it's not information.
Yeah, what's missing? What do we need here, Chandler?
You would need like, so you need to know how long, like what miles per hour we're traveling at.
Very good. The rate, or the velocity or speed, any term for now is fine, of the plane traveling. So there's not enough information. You're missing the R. See the R there? That's what's missing. If you knew the rate of one plane, say one plane was 50, the other plane would be 80. If you knew one was traveling 50 miles an hour this way, one was 80 miles an hour this way, well, after every hour, they go 130 miles. Right? 50 this way, 80 for this guy. So after every hour, they'd be separated by 130 miles. Then you can figure out when they'd be 1,200 miles apart. But unfortunately, we don't have the rate. That's what's needed. Okay, so there's one piece of info missing. It's the speed of either plane. Because if you know the speed of the faster plane, you can subtract 30 to get the slower. If you know the speed of the slower plane, you add 30 to get the faster. But in reality, unless you have that, you can't do this. And let me prove it to you mathematically. So if we want to figure out when they'll be 1,200 apart, we could say that the distance apart equals the sum of the rates times the time that has elapsed. Well, we know that they want to be 1,200 miles apart. The rates are r plus 30, and that's multiplied by the time, which is unknown. Why am I able to do this, r1 plus r2? Has anyone picked up on this by now? It's not obvious. Say we got these two erasers, right? And let's say this eraser is stationary. And this eraser starts moving away at a rate of 2 centimeters per second. 2, 2, 2, 2, etc. Okay? The gap that's spreading here is 2 centimeters every second. So after 5 seconds, they'll be 10 centimeters apart. But if this one were moving in the other direction, the gap that's spreading is caused by both rates now, isn't it? That's the sum right here, r1 plus r2. So if this eraser is moving at 3 centimeters per second, this one at 2 centimeters per second, after a second, how far apart are they? Because you added them together, right? So really, you can think about the sum of the rates if they're going in opposite directions, always. Whenever two things are going in opposite directions, sum together the rates of change, and that's the overall speed at which the gap is expanding between them. Every second, 5 centimeters, 5 centimeters, 5 centimeters. So that's because this is moving at 2 and this is moving at 3. So in this problem, since they're moving apart from one another, I wrote this as the gap between them, d, is equal to the sum of their speeds times the time that's elapsed. But our problem is to figure out the time elapsed. So I don't know the time elapsed. But to figure out the time elapsed, I've got to have one of the rates. Because clearly here, we have two variables and only one equation. It cannot be solved. Okay, all you're told is that they left at noon. That's it. And then it said at what time. So our goal was to determine this part right here. But since we don't have these, we cannot do that. Okay? Questions? Does this portion make sense? Please ask if this doesn't make sense. I'll try to re-explain it. The R1 plus R2.
It makes sense.
Yeah? We're all getting that? The whole gap spreading every time? Good. Other questions on the homework? Today's lesson is pretty short, so I want to take as much time as we need to go over homework. How many questions did I give you total? 5 or 6? 5? There was nothing harder than 13? That was the hardest one? Yeah?
I know, I struggled on the last one.
What number was the last one?
18.
18. Let's just take a quick. Number 18 is the same instructions as number 13. So either solve it, identify if you're missing info, or identify if you're giving too much info, and you could probably still solve it. All right, 18 says, a school cafeteria sells milk 25 cents per carton. That's what I think about right away, right? 0.25 slash or per carton. And salads are 45 cents each. One week, the total sales of these items was $132.50. How many salads were sold that week? Okay, so we have 25 cents per milk carton, 45 cents per salad. We want to know how many salads were sold. So really we need to know how many milk were sold and how many salad, both in a sense. So we need to know two things we're looking for. Problem is, we're only going to have one equation to use again. We don't have two equations. So here's the equation we're going to write. So we could say that the amount of salads sold, or let's say milk cartons, X, times 25 cents per milk carton, plus the amount of salads sold, which we don't know anything in terms of X, so that's got to be Y now, times 45 cents per salad, is equal to 132.50. We're going to do this kind of a problem in section 3.5, but we still wouldn't be able to do it yet. Because how many variables do you guys see? Only one equation. Okay, two variables, one equation. You need another piece of information. So, if I told you that at the end of the week there were 300 items sold altogether, you could write X plus Y equals 300. The amount X is the amount of milk cartons sold. Y is the amount of salads sold. So if I knew some relationship that told me about X and Y and how they correspond to one another, we could solve this. Like we did with the record sales. Remember with the record sales? We were told that the person sells 30 more or something like that, or whatever it was. That gave us the other piece of information to write. But here, this is the problem. X and Y are completely independent variables, and there's no relationship between the two. And if I told you that there were 7 more salads sold, 7 more than milk, instead of a Y here, just put X plus 7. X is the amount of milk cartons sold, and if there are 7 more salads sold than milk was sold, you can instead of put a Y here, put X plus 7, and then you could solve this. But you're missing a piece of information that relates the amount of milk and salads sold with respect to one another. Either the combined amount sold, or how much they sell with respect to each other. One sells double the amount, one sells 5 more, but you need another piece of information about the amount of those items sold. Okay, so it's the amount of items sold that is missing for information there. I didn't write this, but I should start doing more of this. X is the number of milk sold, okay, and Y was listed as the number of salads sold. Okay, let's not forget to do this. I didn't write it because I was talking, but I should be writing that every time. All right. So, 1.9 was very similar to 1.8, word problems, but you kind of did more solving with 1.9. If you, well, actually, you know what? Instead of, let me just pause this because we're going to get on the notes now.